Hi guys, all right, you're welcome to my channel. Now, this is a continuation of our previous exercise where we discuss about logic practice, okay? How to understand your logic circuit and use it to control a particular process, okay? We said, okay, we're going to convert the logic practice into a schematic diagram so that you understand the life situation of the application. And we also give various examples where you can use them and they apply them to real life situation and use them to control a particular process. One of them is using workstation, yes, to using our start station to control the equipment from various locations. So this example of the logic schematic, I want to convert this the particular logic we discuss about. So let's just put up a schematic to control that particular um, process. So this is my supply. Okay, I feed my MCD protection device. So this is lashing circuit. Okay, you should also know about lashing circuit. So I will feed my relay. Let's take this one down a little. Okay, make sure you watch that exercise so that your understanding with this will flow better. Okay, all right. So now let's create a start station to control equipment from various locations. That's what we are doing, okay? Now, I'll send it this way so that I can control the equipment from any location. Okay, just a quick one, just hold on. Supply to all the locations where I want to control the equipment from. Okay, location 1, S1, S2, S3, S4. There are different locations you can control this particular equipment, okay? Now, this is a lashing logic. From here to here and here is called lashing logic. This one. Use this one to lash this motor. Okay. By pressing this, any of this can lash and continue that same operation. All right. Now, how do we shut down the operation? Because the stop button is very far from these locations. So we can only activate the system get deactivated automatically. So how do we do that? Is by introducing a timer. So let's see how we can introduce a timer. Okay, so we're going to have a timer here. Let's say T1. T1 mean timer 1 because we're using 1. Sorry, let's set the time. Supposing I want the equipment to shut down by 4 seconds, or let me say perhaps 6 seconds. Okay, just for practice sake. Now the system get energized. Immediately you activate any of these switch, the system get energized. So let's get auxiliary of this particular one and put the auxiliary here. Okay, don't just worry yourself. This is just for education purpose. By the time you register the program, the whole of this will just be like ABC to you. Okay, all right. Change this to A1. All right, I'm trying to walk you through how start station can operate and how you can also apply the start station to your various equipment design. Okay, all right. Now let's now simulate the workstation once more. I told you that it can only activate the machine will deactivate by itself, but peradventure you want to also deactivate it, we still have button here you can use to activate if you so wish. Okay, I just give example of some method in which you can design a machine to operate a particular sequence to use the logic of a start station to achieve that particular function. All right, so let's do that now. Let's simulate. Just watch this particular equipment close upon activating any of this. All right, okay. I think we can also put attach. You can also attach a signaling lamp. We can do that. So let's see if we can. If I see space, just hold on. Let's move. Let's move this away. We have done that before, so let's take this away. Our previous exercise, we discussed about this. So let me take it away. The subject of this, the objective of this practice for you to understand your logic practice and they use that logic to control a process. You know, you remember that our school days, we have talked about this logic, this logic gate. So, but most of us we don't know the application of this. So I'm trying to bring in the application to your doorstep so that you appreciate the lecturer that taught you this. So you will not say that they scam you, they teach you what does not have application. It does, my dear. It does. Okay. So let me show you the application now. Just hold on. I'm trying to create a space. I have a very tight space factor here. Okay. So now let's see if we can introduce a lamp. Want to introduce, we just put up a lamp that will illuminate whenever the operation is active. Let's put a lamp here. All right. That lamp now is to give us a signal telling us that the contactor or the machine is in a closed mode. Okay. So what we're going to do now is to create another contact for the contactor. Going to be a K1. All right. I'm trying to give you the application of your logic gate. Okay. Uh, Part of your logic gate is this. We just did a logic gate. I'm trying to convert it to schematic. I gave you a logic explaining the workstation. That particular one we did was a live workstation. Let me see, for the purpose of those of us that didn't meet that logic, let me show you the logic. The logic was giving us something like this. Okay, using 4 logic to control a particular lamp in a parallel form. That was what we did. Okay. Okay. For the purpose of those of us that didn't watch that exercise, so I'm trying to give you a preview of what we are trying to convert. This was the logic. So we now did something down this way. Put up the logic this way. And we now created an output. We created an output like this. That was what we did. Okay. We'll now send this one like this way. Then we now bring our neutral this side. We said, okay, any of this can power. Let's bring our life here again. This was the logic gate we tried to lubricate by giving the operation, converting it to live situation. Okay, now what we did was that any of this one, whichever one closes, I must have output. If this one closes, I'll have output. If this one closes, I'll have output. Now, what is the application of this? So we are trying to bring the application of this logic, particular logic. That's what we're doing, okay? All right. And we now also discussed that the application of it can be using multiple switches to put on equipment from various locations. And I now brought the idea of 4 managers, different offices, 1, 2, 3, 4, 5. There are different offices located in various areas, but any of them can activate this equipment, but the equipment will shut down on its own when the time elapsed. Okay, it can be anything, it can be water pump, it can be operation, it can be any particular operation sequence. So I'm trying to illustrate this and simulate it so that you know that it's implementable. Okay. All right. So that you be aware, you know that this particular design is implementable. We can actually design it and use it to operate a particular sequence. All right. Just buy the material, design them, connect them together, energize them, use them to control a process. All right. That's what we're trying to do. So now let's control this machine. by using any of these switches. Mind you, I give you a narrative that each of these switch, they are not closed loop, they are not closely located. They are installed in various locations, perhaps about 300 meters away from each other, but different offices. So any of these, supposing 1, 2, 3, 4 are managers, manager number 1 can on the equipment, manager number 2 can also do that just accordingly. All right, so let's now simulate. Okay, now we're going to put on this by the first manager. This is the manager 1. I put on my lamp, put on my supply. Now this man will put on the equipment. Look at the equipment is on and this lamp is on. It will shut down when the time elapses. Okay, all right. No, it didn't shut down. There is an error. That's why I love simulation. There's an error. Let's find the error. Okay, sorry. Look at the error. Instead of T1, we now went and tag K1. So this is T1. So this one should bear the tag of the contact. So this is the error. Change it to T1. All right, now let's simulate once more. Put on the system. The first manager want to put on the equipment. You put on the equipment and the time start counting. So the equipment will shut down when it is necessary to shut down. You shouldn't go to the switch to shut it down. It will shut down by itself. Look at it. It has happened. Now, let manager number 2, the second person, put it on. I can still put it on from my location. The system will still work and the lamp come up. Now, number 3 person can also put it on. Like I told you, this start station will be located in various locations. It can be considerable distance from the equipment, but anybody, any of these managers or personnel or operators can put on the equipment, but the equipment will shut down by itself based on your demand or based on your design. Okay, so we are done with start station logic. Okay, so the next logic now, we're going to find way to reconcile schematic and ladder diagram. So we're going to take away this and replace this with a ladder diagram. All right. If the time will permit, can we do that? Okay, let me see if we can take away this and change it to ladder diagram. I want you to also understand difference between schematic and ladder diagram. Sorry, we're going into another topic. Let me take away this. Let me change it to schematic and ladder diagram. Okay, we're going to convert schematic to ladder logic. Okay, we're going to convert schematic to ladder logic. This is a schematic. So now let's just design quickly. Let's form, put up, we are done with this, please. We are done with this. So what I'm going to do now is, how do we understand this in ladder? Because ladder is the language we use to write program in automation space. So let me take away workstation. Permit me to take away this, okay? Let me take away this by, no, don't worry. Let's use another exercise, okay? Let's use another exercise.